In this video, we are going to focus on identities. Hi guys, it's your boy again, Mr. Richard. So in this video, we are going to focus on identities. Well, let's get started. Identities are very useful in trigonometry, especially when we are dealing with proofs that requires identities, as well as when we are simply trigonometric expression. Consider this identity. Sine squared theta plus cos squared theta is equals to 1. Yes, that's theta, sorry. That's theta. Sine squared plus cos squared is equals to 1. That's a square identity. And this can also be written as, let's take cos, let's transpose cos to the other side. We are going to have sine squared theta, which is equals to 1 minus cos squared theta. We call this, all of this is called square identity. This type of identity is called a square identity. Well, we can also make cos the subject. We'll say cos squared theta. We will then transpose our sine squared to the other side. So it will be 1 minus sine squared theta. Okay, we have another type of identity. We call it tan theta, which is equal to sine theta all over cos theta. So whenever there is tan, you're going to say sine all over cos. So this is what we call quotient identity. I won't dwell too much on proofs. Today I'll dwell too much on simplifying. Yes, on simplifying. Okay, let's get started. Let's say you are required to express sine theta divided by tan theta. Okay, the question says express sine theta all over tan theta as a single trigonometric ratio. Well, okay, this is quite easy to work with this. No? When you're working with this is what you should do. Let's put an equal sign here. We are going to say sine theta. Let's use the division of operation sine division. Then what is your tan theta? We said tan theta is equals to sine theta all over cos theta. So what are we going to have there? We are going to have sine theta divided by cos theta, isn't it? Then the inverse of division, it's multiplication. Oh, yes. So we have where there is a denominator, we'll put sine, and where there is a sign, we'll put cos. So it's a reciprocal, vice versa part. When you're here, remember that cos will become a numerator and sine will become a denominator. So we're going to have cos theta here, as well as divided by sine theta. So we have common trigonometric ratios. They cancel each other here. So note, they only cancel if there's multiplication. So we'll be left with cos theta here. So that's the solution. Okay. Let's say, what about the question if it requires a square identity? Consider this. Sine theta. Okay. Plus cos theta squared. Okay. Minus 2 sine theta as well as cos theta. Okay. All right, you're working with this. Here you will square sine the first term and the last. Ne? So what are we going to do? When we square sine, it will be sine squared theta. Then 2 will multiply everything that is inside the bracket. 2 times cos times sine is going to be 2 sine theta as well as cos theta. Then square the last term, which is cos. You're going to have cos squared theta. All right. Okay, we have minus 2 sine theta as well as cos. Here, I'll write my cos here. Multiply by cos theta. Okay. So from this part, we can see that we have like terms, isn't it? Yes, we do have like terms. 2 sine and cosine, this and this. 2 sine theta as well as cos theta, and minus 2 sine cos theta like terms. So these will cancel, they will cancel each other. We'll be left with sine squared plus cos squared. So what is sine squared plus cos squared? From our study there, when we started, I said that when you're given sine squared plus cos squared, which is equals to 1, this is a square identity, you're going to put 1. So our solution here will be sine squared plus cos squared, which will be equal to 1. Hope you find this video useful. So in this video, I did only focus on how to simplify or express this in a single common ratio. So in the next video, I'll be working with you with proofs. Hope you find these videos useful. Don't forget to subscribe and like. And remember, we love you.